In-class activity 18B, extreme values of rational functions. 1. The graph of a rational function is shown. Identify any points where you think a local or global maximum and minimum might occur. Let's see. We'll do max first. We'll do local, max. Well, if we look in the interval, -1 to about to 0.4, let's see, we see a high point on the graph there. So we get this, it's about, I don't know, 3/4 or 0.75. So -0.75, and then -0.6. Okay, there's a local maximum approximately at that point, and it's the highest point on that interval, which is, we said -1 to 0.4. Yep. Let's look at local min. There's going to be 2 of these. And if we first look, starting on the left, if we look in the interval -infinity to -1, let's see, we have this point. We have -1 point, looks like 8. -1.8, 0.4. And that's on this interval, -infinity to -1. That looks like the lowest point there. And then, how about this point? 0.6, 0.8. And then, here's the interval. Okay. Objectives for the activity. You will understand that to locate maxima and minima of rational functions, an appropriate window on your graphing calculator or app must be set. A single constant scale graph may not be able to display all the features of a rational function. You will be able to analyze the behavior of the graph of a rational function to help determine where maxima and minima are located. Set the window of your graphing calculator or app to get a close-up view of different intervals in the graph. 2, let f of x be defined to be p of x over q of x, where p of x and q of x are as listed here. Part A, the graph of f of x is shown below. What do you know about this function just by looking at the graph? So let's scroll down here. They're going to show us a graph. There we go. Stop right at 2. Okay. Just by looking at the graph, we appear to have zeros. We appear to have zeros at the origin. So we'll put 0, 0 there. And, well, somewhere between, I don't know, 1.5 to 3.5. And we'll just, we said 1.5, so I'll put 1.5 to 3.5. There we go. Also, by looking at this, vertical asymptotes x is equal to, let's see, we have a -2. I'll just go from the left and go to the right. -2, -1, 1, and 4. And horizontal. There we go. When y is equal to 1. Part B, does the graph appear to have any turning points? Meaning places where the graph touches the x-axis or other horizontal line, but does not cross it. And that is no. Each interval of the graph that we can see here appears to always be increasing or always decreasing. So it doesn't appear to change from increasing to decreasing on the graph here, at least from what we can see. Part 3, or number 3, let me scroll up. It says consider the interval -2 to -1 on the graph above. So let me keep the graph in the picture here. Part A, what do you notice about this particular interval? Well, from -2 to -1, it's bounded by 2 vertical asymptotes. Part B, for any x in the interval -2 to -1, what is the sign of p of x? Well, all values for p in this interval are going to be positive. Right, part C, for any x in the interval -2 to -1, what is the sign of q? Well, all values for q in this interval are going to be negative. There's various ways that we can go about doing this, but let me just show you one way here. On the calculator, I have both of these entered into my y = screen. P is y2 and Q is y3. And I'm just going to go to the table here. And it says the intervals between -2 and -1. So I'm just going to put negative 3/2, -1.5 here, and then show the, whoops, x is -3 divided by 2. Enter that in. And you can see the y2, which is p, is positive, and the y3, which is q, is negative. So that's one quick way to do this. So what we would get would be, f was defined to be p over q. So p was going to be positive, q is negative, so that would make that entire fraction negative. And that leads us to our part D question. For any x in the interval -2 to -1, what is the sign of f? So it looks like that would have to be negative. Part E, let me continue scrolling up here. It says the function f of x is negative for the entire interval -2 to -1 with asymptotes on both sides. What does this tell you about the behavior of the function between the two asymptotes? Well, since f is negative for the entire interval with asymptotes on both sides, I'm just going to try to do a quick sketch here. So there's this is x = -2, this is x = -1, those asymptotes. And it has to be negative for the entire interval. So I'm thinking the graph must come up and do something like this and then turn around and go back down. So the graph stays below the x-axis. In fact, the graph must follow the left asymptote from the bottom of the screen. And as it goes up, at some point it turns around and follows the right asymptote back to the bottom. So for part F, let's see, considering the interval -2 to -1, does the function f of x have a turning point? Looks like, yeah, we can see that. So yes, there's going to be a turning point. And part G, graph f of x. Set your window so that you can see the turning point in the interval -2 to -1. And then what is the turning point? So I have this graphed over here. Let me go back to the y = screen. We'll turn off those two lines, and then we'll turn on the y1, which is both of those. It's p over q. And then let's just graph this and adjust the window so we can see. it says set your window and what's the turning point. So let me just look at this here. You can see the two vertical asymptotes, one at negative x equals -2, one at x equals -1. And it's going to scroll down until we find it. It's pretty far down here. Oh, okay, so there we can see, and I'll make it a little bit wider. There we go. So for part G, it says set your window so that you can see the turning point. We can see the turning point here in the interval -2 to -1. What is the turning point? Let's see. There we go. It looks like when x is about -1.39 and so forth, y is going to be about -29.6262 and so forth. So let's go back here. And this is part G. And it says the max, we'll say the max is located just about this. Well, -1.397, and then it was about -29.626. Okay, so we have a local max, and that's at -29.626. Part 4, consider the interval 4 to 6 on the graph of f. Part A, graph f of x. Using your graphing calculator or app, zoom in into this interval. What do you notice about f of x in this interval? Okay, I'm going to go back here, and we're in the interval, what, 4 to 6. So let me go way back up until I see the origin. There we go. So from 4 to 6, I'm just going to play around with the graph a little bit here. There we go. From 4 to 6, and we're looking for, let's say, a turning point. So let's see what that minimum would be. Looks like there's a minimum just over 5, so about 5.02 or 06 and so forth. And what was the question? I have to go back and reread it. So we are at part A. It says graph f of x, and we had that graphed already. Using your graphing calculator, zoom into this interval. What do you notice about f in this interval? There appears to be a turning point around just above x equals 5. Part B, is this turning point a max or a min? What is the value and where does it occur? So it's going to be a minimum. It's a minimum. And let's see. Let me go back and peek at the graph once more. Okay. So I'm just looking at the x value and the y value there. So we could put the output seems to be about 0.3569 when x is equal to, it's a little bit more than 5. And I have 5 in the previous part A, but it would be a little bit more accurate here. So there's the x and y value we just copied off of that minimum from the graph. Part 5, consider the graph of f. Are there any other possible intervals where a max or a min might occur? And what are those intervals? Oh, sure. There are several intervals in the graph, or a few more. And there could be maxes or mins, yeah. So we haven't checked the intervals from, it wants us to list the intervals. So there's an interval that's, starting from the left and going up. We're going to go from -infinity to -2. And then we have -1 to 1. There's an interval. And between 1 and 4. So there may be turning points in one or more of these intervals. And that's the end of this video.